All right, we're taking a look at practice question set number 4 this morning, concept 15, which is conservation of momentum. Numeric response number 1 says a proton collides with a stationary alpha particle. Anybody know what an alpha particle is? You guys know what a proton is, right? Okay, it's that thing in the nucleus that has a positive charge. Okay. Anybody know what an alpha particle is? Yeah, it is, yeah. The gold foil experiment, Rutherford, right? If you've taken chemistry, you might have heard of that. It's a product of radioactive decay. But I'll tell you what, you see this question right now, it doesn't really matter if you know what an alpha particle is, or for that matter, what a proton is. Okay, a nice thing about seeing this question right now is that it illustrates a pretty important thing for us. And that is that if you see something that you don't know about or you haven't learned about, it's okay. It's okay. We can deal with that. Okay, we have a collision between a proton and an alpha particle. We could call it ball 1 and ball 2, and it wouldn't make any difference, right? We just need to know the mass of ball 1 and ball 2, or the mass of a proton and an alpha particle, whatever they are, right? Now, later on in the year, we will learn in quite a bit of detail what an alpha particle is and what a proton is. So if you saw this on a diploma exam, you would know. But even if you didn't, it's okay. We can still deal with that. By the way, where do we get the mass of a proton and an alpha particle? If we don't have it given to us in the question, where are we going to find it, Danielle? Yeah, find it on your data sheet. If you're missing something, especially like a value of something, check your data booklet. Okay, find it there. This says after the collision, the proton moves at 3.35 times 10 to the 6 meters per second in the direction opposite to its initial motion. Now, I'm gonna circle this in red because this whole opposite thing is to me is inferring a negative value, right? If it's moving in the positive direction, now it's moving in the negative direction after the fact, right? Opposite direction. Little things, right? Little things like that we want to draw attention to and not miss. The alpha particle moves forward at a speed in the same direction as the proton was initially moving. What was the initial speed of the proton? This is a collision, and whenever we see a collision, we check our little always list over here on the board. Okay, whenever we see a collision or an explosion for that matter, we want to do conservation of momentum. We know that we could do impulse, but if we did impulse, we wouldn't be analyzing the proton and the alpha particle. We would be analyzing the proton or the alpha particle. We'd be doing one at a time. And generally, when we have a collision like this, generally the easiest way to do it is to look at the system, which means we have to do conservation of momentum. So we're going to say Pi is equal to Pf. We have two objects before this collision, m1 v1I. We'll say that's the proton, plus m2 v2I, that's the alpha particle. Afterwards, they bounce off of each other, so we have two objects. So we're going to say, once again, m1 v1F plus m2 v2F. We're good there? All right. I'm going to cross this off. I'm going to X this out. How come? How come I'm going to X that out, Daniel?
The mass is being counted as 0.
Not the mass is being counted as 0.
No, like the initial velocity.
Okay, good. The initial velocity of the alpha particle is 0. So the mass of the alpha particle times 0 is 0. Right, good. Mass of the proton on your data sheet is 1.67 times 10 to the minus 27 kilograms. Times the initial velocity of the proton, which is what we're looking for here, v1I, equals the mass of the proton again, 1.67 times 10 to the minus 27 kilograms, times v1F. It says the proton moves at 3.35 opposite to its initial motion. So I'm going to make that negative 3.35 times 10 to the 6. And I'm going to make the alpha particle's mass is 6.65 times 10 to the minus 27 from your data sheet, times, it moves at 2.25 times 10 to the 6 in the same direction, forward in the same direction, so we'll make that 2.25 times 10 to the 6 meters per second, but positive because it's moving forward in that same direction. Does that make sense? All right, now let's do this. Let's do this together on the calculator. let's do the right-hand side, 1.67. Watch what I'm going to do here with the exponent here, okay? Here's what I see a lot of people doing for, 1.67 times 10 to the negative 27. They say 1.67 times 10 to the negative 27. Okay? That's correct, and it works really well if the number is on the top, a numerator, but if it happens to be a division thing or a denominator, it doesn't work really well. Okay? Your calculator doesn't assume the same order of operations as you do. So here's what I'm suggesting that you do, always. 1.67, second function, EE. Okay, 1.67 times 10 to the negative 27. That ties the exponent in the times 10 to the negative 27. It ties it to the base. It ties it to the 1.67. So your calculator, even when it's on the bottom as a denominator, puts that together and counts it as one number, as opposed to using the other way, which considers them separate numbers. And when it's on the top, that's okay, but when it's on the bottom, that's not okay. So that's what you should always do when you're typing scientific notation into your calculator. 1.67 times 10 to the minus 27 times negative 3.35 times 10 to the 6. Okay, I'll press equals there. Then I'm going to add to that, still on the right-hand side, brackets 6.65 times 10 to the minus 27 times 2.25 times 10 to the 6. There's my right-hand side. Then I'm going to divide that by 1.67 times 10 to the minus 27. And I end up getting 5.61, 5609, or 5.61 times 10 to the, I believe it's 6. Now, there's a typo here. This will not happen on a test. This would not happen on an exam. But there's a little typo here, and I'm sorry for that. It says 8 decimal BC times 10 to the negative D. It should be 8 decimal BC times 10 to the positive D. Okay, which means our answer would be A, B, C, D, 5, 6, 1, 6. Sorry, 5, 6. I got 5, 6, 5, 6 on my. Is it 1, 6? 5, 6, 1, 6? What was it on my? I said 5, 6, 5, 6 on my. Okay. Okay, so it should be 5, 6, 1, 6. Sorry. We good there? I saw a hand up over here. Daniel, was it you?
I was just going to say that.
Okay. We good there? All right. Number one, or multiple choice number one, that is. Says a clerk working at a local food store is asked to retrieve the empty shopping carts left outside by shoppers. Each cart has a mass of 20 kilograms. The clerk places 8 carts, which are locked together close to the entrance on a slight incline. The clerk gathers another 12 carts and pushes them toward the store entrance. Meanwhile, the first 8 carts roll toward the 12 carts with a speed of 2.3 meters per second. This is the first point that really matters here, okay? That's really a part of the problem. We've got 8 carts rolling towards 12 stationary carts at a speed of 2.3 meters per second. Make sense? So 12 are stationary, 8 are moving towards it, they collide, and then they come to a complete stop. 12 are not stationary, it doesn't say that. 8 are moving towards 12 together, right, in a head-on collision, and then they come to a complete stop. What speed was the 12 carts moving just before impact? This is a collision, and in a collision, we're going to say Pi equals Pf, because we always think that, right? Collision or explosion, conservation of momentum. We're going to say Pi equals Pf. We're going to say M1 V1I. We'll say that's the 8 carts, okay, M1 V1I, plus M2 V2I. That's the 12 carts, equals, but technically we should say MT. MT stands for total mass times VF. But what's VF? 0. So what's the total final momentum? If you want to just write down 0, you can do that, right? Without writing that MT times VF term in there. All right. We know the mass. We know the mass of each of these shopping carts, right? The first mass has 8 of them, so it would be 160 kilograms. Agree? The second one is 10, and it's 20 kilograms, so it would be 200 kilograms. Agree? What if we didn't know the mass of each cart? What if we didn't know that? How would we do this then? I'm going to do this as if we didn't know it, because you guys can all multiply 8 times 20 and get 160. Right? So you guys can all do it knowing the mass. Okay? I want to do it if you don't know the mass. Yeah, Thomas?
You put 8 in front of the first step and 12.
Yeah, almost, yeah. Let's say the mass of a shopping cart is, of a single shopping cart is M, or X, or Q, or whatever you want. That's exactly what you do, but you have to see that there's the same variable in each one. So let's call it X. Okay, let's call it X. Let's say the first mass is 8X times V1I, that's 2.3 meters per second, plus 12X times, well, V2I is what we're looking for here. So we've got 2 unknowns here. But the good news is X appears in every term. Actually, it doesn't appear in this term, does it? Is that okay? Yeah. Since it's 0, it's okay. If you divide everything by X, the X's end up canceling out. And you're left with 8 times 2.3, which is going to be what? 18.4? Is it 18.4? Let's take the 18.4 over by subtracting, and we get 18.4 divided by 12, which is, I think it works out to be 1.53. Should actually be negative 1.53, I think, right? But what are we looking for? What have I just found? Velocity. We're looking for speed, and of course the speed is just the magnitude of the velocity, so the answer would be C, 1.53. Does that make sense? Anybody do something like this? Like just say 8, 12 instead of 160 and 200? Yeah? The last question, we could have done something similar to that as well. I didn't mention it because you're not familiar so familiar with protons and alpha particles at this point. But by the end of the year, you'll know that an alpha particle has the mass of 4 protons. It's 4 protons. An alpha particle consists of 2 protons and 2 neutrons, which neutrons and protons weigh to 3 digits, the same thing. So what we could have done up here is said the mass of a proton, called this the mass of the proton, and then called this 4 times the mass of a proton, and then we could have ended up canceling MP out, the mass of a proton out. And then we could have avoided those ugly numbers with the exponents. Doesn't really matter, right? If we know the numbers, with the exponents, then we can use them. If we don't, then we can do the canceling thing like we did in question number, multiple choice number 1. Okay, number 2. A 2,100 kilogram van collides with a 1,200 kilogram stationary car that's at rest. They lock together. They move off at a speed of 4.5. The initial speed of the van is what? This is probably one of the more straightforward ones that we would see, right? We're going to say PI is equal to PF. We're going to say M1 V1I plus, what do you want to say here? Plus what? Well, we could say M2 V2I, right? Or we could, if we wanted to, we could just say plus 0, right? Because it's at rest. The second one's at rest. Now afterwards they stick together, so we're going to make it MT times VF there. M1 is 2,100 kilograms times V1I equals the total mass, which is 3,300 kilograms, times VF, which is 4.5 meters per second. So multiply those together, divide by 2,100, and it works out to be 7.07 meters per second. And we just fill it in as 7.07. Okay, if this was an actual answer sheet. Okay, that's certainly one that we want to get correct, right? That's one that that we need, come test time, we need 100% of people to get that one right, okay? No signs, no positives, negatives that we got to worry about, no tricks to that at all. That's just one that we can, 100% of us can nail. And finally, numeric response number, or multiple choice number 2, talks about these bumper cars. Too bad they don't have the same mass. If they had the same mass, we could end up canceling it, right? Bumper cars operate on electricity. The more the accelerator pedal is pressed, the more current flows in the system, thus the faster the car travels. X and Y are going to collide head on. X is traveling at a constant velocity of 2.25 to the east. Y is traveling at a constant velocity of 1.30 to the west. Draw attention to it. Okay, please don't skip that step. Now, you're doing this online last night. Okay, you can't circle it when you're doing it online, right? But on scrap paper, you can make yourself a little note, which is the equivalent of circling it in red or something, right? After the collision, Y is traveling to the east. What's the velocity of X? We're going to say PI is equal to PF. How many objects before the collision takes place? 2. M1 V1I plus M2 V2I. 2 objects, we're going to have 2 terms. Equals, how many objects after the collision takes place? 2. Now, like when 2 things stick together, people might think of it as 2 objects, but understand that it's not 2 objects any more than, we would consider you and your shoe to be 2 objects, right? If we were analyzing a collision between you and another person, right, we would consider you and your shoe to be 1 object and the other person and their shoe to be another object. Your shoe is part of you. Well, when 2 things collide and stick together, then if they stick together, then it's 1 object, just like you and your shoe are 1 object here. These two things bounce apart, so there is going to be two terms, M1 V1F plus M2 V2F. Mass 1 is 125 kilograms. V1I is 2.25. M2 is 161 kilograms. And V2I is negative 1.3, 1.3 to the west. M1 is 125 again. We're looking for V1F plus 161, and this one's going off at 0.526 to the east, so it's positive. Okay, let's get the left-hand side here. 125 times 2.25. I'm going to subtract brackets 161 times 1.3. See why I've subtracted there? We could add and then make 1.3 a negative value, or we could just subtract. This gives us our left-hand side. And then we're going to subtract from that 161 times 0.526. If you're having trouble with the algebra here, let me know. Divide by 125. Negative 0.10, nope. I have on my answer key B, but I think it's A, isn't it? Yeah. What did I have on the online answer key, A or B? D? Wow. So that's negative 0.102. So the answer would be A.